All right, so graphing quadratics, we've talked about graphing them from vertex form. Standard form is ax squared plus bx plus c. So what we're going to talk about now is graphing quadratics when you're given the standard form. All right, so when you're asked to graph a quadratic from standard form, there's two methods that you can know. So method number one, you're going to change it from standard form to vertex form. So that's what we're working on already. So we take our standard form equation, we complete the square, which we go from here. Half of that number is 2. 2 squared is 4. I'm going to, I needed to subtract 4 off the end there. I actually did it just a little bit wrong, needs to be fixed. So when I subtract 4 off the end, not add it, I get negative 11. Okay, so then I would just graph it from there, just like we've been doing in the vertex form. So we have just the next level harder we talked about. We would need to undistribute that 2 first. Then we take half of 6. Half of 6 is 3. 3 squared is 9 times 2. All right, is 18, which I subtract off. I did that properly. Kind of proud of myself there. All right, so I've got 2 times x minus 3 squared minus 13. So we moved to the right 3. We moved down 13. We stretched it by 2. Okay, so you would just graph it from there. There is another method, and it's called using the axis of symmetry to find the vertex. So what you do is you look at it in standard form, and you're going to pull the a and b from the original equation. So if we have it in standard form, where ax squared plus bx plus c is your equation, the number that would be in front of x and the number in front of b are what numbers go into our axis of symmetry equation. So when you plug in so once you use that a and b and come up with a number at x equals, that's your x value from your vertex. So you put that x value back into the equation and get the y value and graph it. So an example like this one. If I'm telling you to graph this, my a equals 2 and my b equals negative 12. So what I'm going to do is put positive 12, because it's the opposite of b over 2a. So positive 12 over 2 times a is 2. 12 over 4 is 3. So my vertex starts with 3. I need to figure out what that y value is, so I'm going to plug 3 back into the equation, and my y value is negative 13. So my vertex is at 3, negative 13. From there, I create a table of values. So I put in my 3, negative 13 in the middle. I'm going to pick a couple points on each side. I'm going to plug them all in, and I'm going to get these points. Now graph. Now, if you don't want to do all of that, you can just scratch it. Use that table function that we may have talked about. So I'm going to go and I'm going to hit table. I want to edit the function. And instead of what's there, I'm going to clear that out. And I'm going to put in the equation that I had. So going back to that equation, 2x squared. So 2x squared. Let's take a look. Am I on the right track? Okay, minus 12x. All right. Plus 5. Okay, so now I'm going to go to that table of values. Now, it would still be good to know where your vertex is, because when I hit enter all those times, I'm going to get this table of values. So I would like to look for that middle, that mirroring effect that you end up with. So what I'm looking for is where it's negative 11 on either side. So I'm going to go to where x equals 3 is in the middle. And there's that mirror that I'm going to look for, negative 11 on top and on bottom. So this is where I could just copy down this table from my calculator. So 1, negative 5, 2, negative 11, 3, negative 13, 4, negative 11, and 5, negative 5. And just plot your points and graph those.